Okay, we're ready for the final calculation. It involves all the steps we've used so far and not really that much more. We got to be careful how we read this. We want to find the chance x is between 14 and 24. It's allowed to be 14 because there's an equal sign under that inequality symbol. And there's also allowed to be 24 because there's an equal sign under that inequality symbol. So down here, 12, that's 13, that's 14 should be there. And 24, 24 is already on the list. Oh, so there's 24 already there. So we're going to find the area from here all the way over to here, because we need to include 14 and 24 in our calculations. So let me zoom in on that so we can see it a little more detail. So there it is. 12, 13, 14, then 15, 16, and then over there is 24. And so that means we're starting here at 13.5, and we're going all the way over here to 24.5. So we're going to use those two numbers in our z calculation, and we're going to find the area under a normal curve. I'll try to draw it better this time. It's difficult to do. Okay, more like this. There we go. It's pretty close. We're going to use the area under the curve to estimate the area of those little rectangles. And you see how the curve cuts through. The curve is passing through these bars, and so the area under the curve will include this little piece here. That little white piece there will be under the curve. It'll compensate for us cutting off that corner to some extent. And that happens throughout the graph. So it does a pretty good job of estimating the area under those rectangles. The curve does, because the curve, where it is above the rectangles, gives you a little bit extra, and where it's below gives you a little bit less, but those two cancel each other out. So we're going to go ahead and compute some z's. So we'll go z for 1. So remember, z is x minus mu over sigma. We're going to do it for 24.5. 24.5 minus 18. 1 point, I lost what it was. I think it's 1 point, what was it? 1.1464. Sorry, 3.14. 3.1464. And the other z, I'm going to be using 13.5 minus 18, or 3.1464. There we go. And then I've got it, oh, I'm zoomed in. Well, that's okay. I'll zoom out a little bit. There you go. I will then crank up the old calculator, clear that. I'm using parentheses this time. 24.5 minus 18, close them up, divided by 3.1464. Go ahead. 2.065, so 2.066, put it in there. We only get 2.0, just 2.0, we only get those two places. So it's going to be 2.07. I'll put what it is. 658, we'll say we're going to use 2.07 because we only get to keep two places. And then I'm going to go second enter to retype that. I'm going to come back here and replace the 24 with 13 because that was the other side. I have to wait for it. There we go. 13. Do I have to scroll over? No, I don't. Okay, 13. Okay, look, see what it looks like. 13.5 minus 18. Okay, looks good. Crank it up. It should be negative. Negative 1.4302. So we're going to use negative 1.43 because we only can keep two places. And then we're heading over to the tables. The tables for 2.06. So let's, where are they? Here we go. We're in here. I'll zoom in a little bit. 2.06. I have to remember not to forget. How about that? To unzoom. 2.06. So there's 2.0 right there. And we're going to go over to 6. That's 6 up there. It's all going to come down to 2.0. Okay. 9803. Okay, 0.9903 for 2.06. 0.9803. And then we're looking for minus 1.43. Try it again. Minus 1.43. I'm gonna make sure I can see everything. I think we're okay. Minus 1.4 is here. I'm gonna go over to 3. 1.43, 0764. All right. 0764. There we go. And then, since we want the area in between the two, now we subtract areas. So 0.9803. So 9803 is from here on back. That's almost the whole curve. 0.0764 is about 10%. So about 10% of the curve is here. It looks approximately right. And then we'll just subtract those two. 0.9803 minus 0.0764. Okay. 0.9039. 0.9039. And that completes that example. I don't think there's anything more underneath here. No. So those are using the standard normal tables and z-scores to estimate probabilities in binomial distributions where we know n times p times 1 minus t is at least 10. I said n times p times 1 minus p is at least 10. 9.9, pretty close. We cut it by a whisker. I think that's close enough. Ordinarily, you'd make sure it's at least 10. Well, we're so close, I took it anyway. And that's the end of that. And I guess I'll stop recording.